slope, and slope actually has a ton of uses. Okay, like we can describe slope. We've already described slope as a rate of change. Okay, so if we want to find the rate at something changes, we can also find the slopes of objects. And when we find the slopes of objects, that's just a measure of how steep they are. Okay. So for example, you know, I mean, you want to determine whether ramps, any kind of wheelchair ramp is safe, it has to meet a certain condition. Okay. So in Winnipeg, a city bylaw states that the ramp must have a slope not greater than 1 in 12. That means for every 12 units that you move horizontally, it can only go up 1 unit vertically. So like if you had a 12-meter long ramp, the maximum height of the ramp could only be 1 meter. If it's higher than that, too steep, they won't allow you to build it. So we're going to talk in this one about how we can use the slope of objects. And we've talked about how slope means vertical change over horizontal change, or change in the dependent variable divided by change in the independent variable. Another way that you guys should have all seen from grade 10 is slope can be considered rise over run, because rise is vertical, run is horizontal. So it's the vertical change divided the horizontal change. So all of these things have the same meaning. We just use different words. Like we're going to talk about how we can do exchange rates. And you actually use slope to do exchange rates. Okay, so slope has a ton of different uses. Okay, so just looking at this, here's an example of a ski jump hill. So here's the photo of it. Here's a diagram of a cross section of it from the side. Okay, like if you could see through the snow. So you could see that for every horizontal distance of 72 meters, we go up 100 meters. We can use this to measure how steep the line is, or find its slope. So to find its slope, this is where we think of slope as rise over run. So the rise is 100 meters. The run is 72. So that works out to 1.4. What exactly does that mean? That means that for every 1 meter you move horizontally, you go up 1.4 meters vertically. So for every 1 meter you move horizontally, you move 1.4 meters vertically. So this one's all about finding the slope of objects. What we've done before with slope is we found it as a rate of change, and we're going to go back to that before we finish this unit. Okay, so where else could we use this? Ramps, hills, we can determine the slopes of, okay? Here's another place where we can use it. Yes, well done. And how steep a roof is, and whether it actually has a constant slope. Because if you have a roof that doesn't have a constant slope, you're probably going to have some problems. And it's not just with your roof. It could be with what ceilings inside your house, like me. Okay? I've got a corner by my front door that it peeled off the plaster when it got warm because something was leaking through. So something's not right. Something's not flush. So here's an example. So Penny and Sam are looking for a house. They find an old home they like. They are, however, concerned about the amount of work they need to do to repair it. So they've taken measurements and they want to see if the the roof has a constant slope. Okay, doesn't have to be exact, but it should be close. So we're going to take a slope. We're going to measure the slope at two different intervals. We're going to measure the slope here, and we're going to measure the slope here. If they are about the same, then we shouldn't have any concerns about the roof. And remember, slopes of objects is just rise over run. So I'll just call it interval 1. So that's the purple one. What's the rise of the purple one? What's the run? 2.5. What's the run? 6. Good. So 2.5 divided 6 gives us about 0.4167. So now we want to measure the slope of interval 2 and see if it's close. So the slope of this one would be a rise of 5, is that 5.2? Yeah, 5.2. Divide a run of this entire thing here, 12.4. Which gives us about 0.4194. Exactly the same? No, but pretty close. Okay, I mean 0.417, 0.419 if we went to 3 decimal places. That's pretty close. Okay, so I don't think they need to worry about it. Remember, it doesn't have to be exact. Okay, so we would call it a constant slope. They're okay. Okay. Doesn't have to be exactly equal. We tried the next one, do it the same way. This guy's remodeling the house, needs to see if the roof needs to be repaired. So again, we just do, it's the same steps. For this interval, it's a rise of 4, divide a run of 10. Slope equals a rise of 4 over a run of 10. And then just divide it and express it in decimal, because decimals are easier to compare than fractions. For the second interval, we got 16, a rise of 16 over a run of 25. So the slope is going to be 16 divided by 25, which when you change that to a decimal using your calculator, you get 0.64. That's pretty different. 0.2 and 0.6. Okay. So that's, we would consider this not a constant slope. Not a constant slope. So he would need to repair. Yeah. Would you like me to?
Yes, please.
Okay. So ramps, roofing, hills, those are the types of objects that we can use slope for. One more way that we'll look at, and this is something that you should all have some experience with, trigonometry. But it's the most basic trigonometry we learned in grade 10 to start. Okay? It's nothing complicated like sine and cosine laws, which aren't that really complicated, or the unit circle or radians or things like that. You don't have to worry about those. We're keeping it simple. Okay? We're just looking at where it's applicable. Back in pre-calculus, you would do all the math, but a lot of times we didn't have word problems, or they were very rare. Okay, here, this is all about where do we actually use it? Well, and we're going to do sort of a mini unit on trig later on, but this is sort of a quick review of trigonometry. That there's three ratios in trigonometry, and what do we use it for? We use it to find missing angles or missing sides. That's the purpose of it. Okay? So if I know what this angle is, and if I want to know what the opposite side is, and I want to know, and I know the hypotenuse, then I use one of these three. If I know the adjacent and I want to find the hypotenuse, I use another one of the three. Okay, I'm not going to go into a big description of trigonometry today because we're only going to do one question, one type of question where you use trig. We're going to focus on this one, on tan or tangent, because the tangent of an angle is always the measure of its opposite side over the adjacent side, which we've just been talking about is rise over run. So we can use slope in trig to actually find the angle that something is tilted at, or what we call the angle of elevation. So an angle of elevation is just an angle formed between a horizontal line and looking up to something. That's what an angle of elevation is. Okay? Let's look at an example where we would use this. Okay, come on. There we go. So we've got a kite in the air. The slope of the string is 5. That's enough information to find the angle of elevation. If the, remember what slope is, rise over run. So this would be rise, wouldn't it? And this would be run. So doesn't that mean that this must be 5 and this must be 1? Because a rise of 5 divided a run of 1 gives me the slope. Okay? the slope will also equal in trig opposite over adjacent, which is tan. The slope of some object will always equal tan theta. So that means in this case, the slope is 5. Tan theta is equal to 5. This is for those of you that may not be familiar with this symbol. It's like a 0 with a vertical bar through it, or a horizontal bar through it. It's called the Greek letter theta. We often use it when we talk about missing angles. I mean, we could have called this X, we could have called it A, but a lot of times in math we use this one, this symbol. So we got to figure out what this is. This is equation solving. Do you remember how to get rid of a tan? How do you get rid of a tan? Cool, come on. What's the opposite of squaring? If you square something, what's the opposite? It goes backwards, square root. Okay? If I times something by 5, what's the opposite? Go back. Divide 5. If I subtract something by 7, what's the opposite? To go back. Add 7. If I tan something to get an angle, what's the opposite? To go back. Tan inverse. So I've got a tan inverse. A tan inverse, which we write as tan to the -1, and a tan will always cancel each other out, which means we'll be left with theta, which is what we're trying to find. So we need a scientific calculator to do the tan inverse of 5. So you should all have a scientific calculator available to you. That's only for sine and cosine. It's okay for tan. So if I do second tan of 5 on my calculator, I get 78.6900. So I'm going to round it to, the angle is about 79 degrees. So we can use trig with slope to find angles of elevation, which also tells us how steep something is. Because obviously, the bigger the angle, the steeper it is. Like, would you consider this pretty steep? Almost getting to the close to vertical? Yeah, it's pretty steep. Whereas if it was like 39 degrees, then the kite would be out there somewhere. Whereas 79, the kite's going to be up here. So that's where we can use trig. Finally, with safety, we talked about the bylaw in Winnipeg for wheelchair ramps. Okay. There's also recommendations for how much you should lean a ladder that a lot of painting companies use. Okay. Because I mean, if you don't follow the proper procedure and something happens to you, you may not be liable for, or you may not benefit for any compensation if you injure yourself because you broke the code. So you want to be careful. That's just one example. So here we have a ladder. What's the slope of this ladder? 4. Rise over run. Slope is rise over run. The rise is 4, the run is 1. So the slope is 4. That means for every 1 unit, whether it's centimeters or whether it's meters, okay, that we move horizontally, we move up 4 of those units vertically. As long as the slope is less than this, then you're okay. So you want to know the height at which you're leaning the ladder, and you want to know how far away you are from the building. That determines the slope. That determines whether you're making your ladder too steep. So let's look at these ones. 3 examples here. We want to find the slope of each and determine whether they are safe or not. Remember, it's got to have a slope of 4 or less, not more. Because if the slope's higher than 4, that means it's steeper and unsafe. A and B are good, C is not. Yeah. The slope here, remember, rise over run. 6 divide 3, which is 2. Yep, safe. Slope is 9 divide 2, which is 4.5. Not safe. That's higher than 4. You're risking injury there. Yeah, this last one. You got to imagine this ladder is flat, right up against the wall. There's no, it's not out at all. What would the slope be? There would be no slope. We couldn't measure it because if you think about it, the slope is the rise of 10, but it doesn't run anywhere. It's right up against, like it would look like if you're looking at it from the, this is looking at it from the front. If you looked at it from the side, like the ladder is right up against the wall. What's that? Yeah, that's pretty, I don't think you have to do a lot of math with that one, okay? But the run would be 0 because there is no horizontal length. And we can never divide by 0. So it's undefined, and yes, definitely not safe. So that's 2 special cases. Whenever you have something leaning against something else, there'll be a slope. But if it's right up against it vertically, it's undefined slope. What happens if the ladder was on the ground? The slope is 0. So a horizontal segment has a slope of 0. A vertical segment has an undefined slope. Okay. We're going to go back and talk about slope as a rate of change, and we can use it in scale drawings. Okay. We can use it in like converting currency. So like I said at the beginning of this, slope has a ton of different uses.